This is section 6.5, theorems about roots of polynomial equations. Your vocab term is rational roots theorem. And the rational roots theorem says that in a polynomial equation, the factors of the last term over the factors of the first term are going to give you possible zeros of your function. So we're going to list out all the factors of the last term and over the factors of the first term and divide them. And then we're going to use synthetic division to figure out which zeros there are. But those are on your VIC, so we'll talk a little bit more about what this means later. And we also have as a vocab term irrational or complex roots theorem. And that says if a plus bi or a minus the square root of b is a root, so is its conjugate. And we're going to do more with this on Tuesday and Wednesday. This just needs to be written down so you have it, so you know it, so we can go back to it. For VICs, you have, when listing the possible factors, always use a plus or minus sign. So if your number that you're looking at is a positive number or a negative number, you're going to write it as plus or minus because it could be either one of those. You're going to list out every single combination, and there's going to be a lot for some of these. You're going to use synthetic division or the remainder theorem to determine if P over Q is a factor. And P is all the numbers that are factors of your last term, and Q is all the numbers that are factors of your first term. So when we list them out, when it says list out every combination, that's what you're going to do. You're going to separate each one of those fractions that we write as one whole number. And then remember that if it's a factor, your remainder is going to be 0, and that's how we're going to determine if it is a factor or not. So for example 1, it says list out all possible rational roots for 6x to the third minus 3x squared plus 7x minus 9 equals 0. So my factors of negative 9, because that's my last term, that's my constant term, are plus or minus 1, plus or minus 3, and plus or minus 9. And my factors of my first term, this is your leading coefficient, is 6. They're plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So those are all the numbers that go into negative 9 and into negative 6. So when we list them out, we're going to list them as plus or minus 1, because 1 over 1 is 1. Plus or minus 3, 3 over 1 is 3, plus or minus 9, because 9 over 1 is 9. Then we're also going to list them as plus or minus 1 half, because you have 1 over 2. Plus or minus 3 halves, you have 3 over 2. Plus or minus 9 halves, you have 9 over 2. You have plus or minus 1/3. Plus or minus 1, you don't have to list twice. Since 3 over 3 equals 1, and we've already listed out 1, you don't have to list it twice. And then you have plus or minus 9 over 3, which equals 3, so you have plus or minus 3. And with my last term, you have plus or minus 1/6, plus or minus 3/6, which simplifies to 1/2, and since we already have it, you don't have to list it twice. And plus or minus 9/6, which simplifies to 3 over 2, and since you already have that, you don't have to list it twice. So listing them out, you're going to do exactly what I said, and write down each combination of terms, each fraction that you pull apart from this set of numbers. Example 2, we're going to go through all the steps. We're going to list out the possible roots. We're going to use synthetic division to figure out which one is a factor. We're going to simplify and then solve. So find all roots of 2x cubed minus 5x squared plus 8x minus 5. So I have all the possible roots are plus or minus 1 and plus or minus 5, since those are the factors of 5. And plus or minus 1 and plus or minus 2, since those are the factors of 2. So I have factors of my last term over factors of my first term. So my possible combinations are 1, plus or minus 1, plus or minus 5, plus or minus 1/2, and plus or minus 5/2. So I'm going to list them all like that. When you use synthetic division or the remainder theorem to figure out if 1 is a factor or not, I would start with your 1. So try 1, try negative 1, try 5, try negative 5. These fractions I would try last. Don't try them first. Try your whole numbers first. So if we do synthetic division with negative 1, you bring the 2 down and multiply, you get negative 2, add, you get negative 7, multiply 7, add, you get 15, multiply, you get negative 15, adding, you get negative 20. So I know that this is not a factor. So negative 1 is not the one I want to use. So I'm going to go to positive 1. If I do synthetic division with positive 1, I bring the 2 down, multiply, I get 2, add, I get negative 3, multiply, I get negative 3, add, I get 5, multiply, I get 5, add, and I get 0. And 0 is what I want. So I found one that works. My remainder is 0. So this is the one that I want to use. So if I'm simplifying this polynomial, I'm going to write it out as x minus 1 just like when we wrote in linear factorization, you do x minus 1 because this one worked, this one gave you remainder 0, times 2x squared from this 2, minus 3x from here, plus 5 from there. Now, the extra step, so you've written your answers out like this before when you had remainder zeros, but your next step is to take this polynomial and either factor or use the quadratic formula to simplify it even more. So 2x squared minus 3x plus 5 does factor more. So I can take this x minus 1 stays the same. 2x squared minus 3x plus 5 factors to 2x minus 5 times x plus 1, where you want to set each piece of these equal to 0. So x minus 1 equals 0. Your 0 is x equals 1. 2x minus 5 equals 0. Your 0 is 5 over 2. And x plus 1 equals 0. Your 0 is negative 1. So if you're solving for all the zeros, you want to list your possible roots, pick one to do synthetic division with, or you can always use the remainder theorem. When you find one that gives a remainder of 0, you want to simplify it by writing it out in linear factorization. And then you'll probably end up with a quadratic. And with that quadratic, you either want to factor it more if it's factorable, or use the quadratic equation so that you get 3 different zeros, or as many zeros as that polynomial has.